We got a new player in town, guys, and this is it. This is a new AIO from DeepCool LT720. This is a 360mm AIO, which we will test out today and talk about all the details. But check the lock top. I mean, this looks quite cool and something different. We haven't seen this one before, and I do have to say, quite interesting, slick design, minimalistic, yet it does have some cool features, well, cool design on the pump block top. So let's dive into specifications first to check out some details and what we get compared to the past models, and then we're going to test it out on Intel Core i5-13600K. So as any DeepCool AIO, so far it has a anti-leak tech inside, which is the new standard of liquid cooling systems, but basically we've seen that in loads of DeepCool AIOs. So what we got here is the squeezed state of the rubber that's on the side, coolant pressure, and then we have the air exhaust. So this is really cool because the liquid cooling radiator features low noise, high radiation efficiency, and because of that its potential safety hazards shouldn't be ignored. Now, when the pressure exceeds the system critical level, a leakage will occur. Even though honestly I haven't encountered a situation where the AIO leaked, but nevertheless it's a cool feature, and I think DeepCool went a bit further into details and definitely into some sort of a technology that prevents the possibility of happening. Now, for the compatibility, we have the LJ2066 2011, 2011 V3, 1700, 1200, 115X. It covers all Intel sockets, and we have the support for AMD TRX4 and TR4 AM5 and AM4. So basically the LT720 covers all sockets and all CPUs, which is outstanding. The radiator dimensions are 402 times 120 times 27 millimeters. Tube length is 410 millimeters. Pump dimensions are 94 times 80 times 68 millimeters, which I would say one of the largest in terms of guessing, I would say. The pump speed goes up to 3100 RPMs plus minus 10%, and the pump noise is up to maximum 19 decibels, which is outstanding. The pump connector is 3-pin 12 volt VDC, and the power consumption is 4.56 watts. We have 3 fans with the dimensions of 120 times 120 times 25, which make the total thickness with the fans and the radiator 52 millimeters. The RPMs of the fans are 500 to 2250 plus minus 10%. The airflow is actually outstanding, 85.85 CFM with air pressure going up to 3.27. Fan noise is maximum 32.9, and you have a 4-pin PWM connector to adjust the speeds. So that was quick for specifications, and I do have to admit it really does look quite interesting. Compared to other AIOs they created, they all looked really nice, I do have to say. But this one is specific. I don't know if it's kind of reminds me of Minecraft because of the square shape and stuff like that, and the squares inside as well, with some sort of a mirror effect going deep inside the block, but that's only my opinion, of course. You have your own idea how it looks and what it resembles to. But here we go. So we have 3 fans on the radiator. I placed it on the front of the chassis, and the tubes are a bit too long in that terms, but nevertheless this will give you space to maneuver. The only problem with everything, basically the only con I would say with this AIO, is that it has a fixed position of the LED top and you can't rotate it. If you, for instance, want to place the tubes on the left side, on the top side, or on the right side, the logo will follow the tubes, because there's only one cutout, and that cutout is designed for the tubes to be at the bottom part. Which, okay, I don't mind where the tubes are, but if you want to reverse them or just to lose the tube length in a shorter case, then you'll have to sacrifice the logo being OCD free and in the straight position. But okay, that's the only thing that is, I don't know, in the way. So how do you actually place the pump block top on the processor? You have, for instance, for Intel and specifically for the LGA 1700 and basically for the 1200, you have two types of plastic standoffs. So you put a backplate that comes with the AIO at the back on the motherboard, and you have two holes for the mounting screws, so you can adjust them. The further hole from the center is for the LGA 1700 and the closer one is for the LGA 1200. Placing it at the back, you get the standoff screws on the front part of the motherboard, and you have two types, as already stated, plastic standoffs. Ones are for the LGA 1200 and 115X, and the other ones are shorter and they are designed for 1700X. If you use the wrong ones, for instance 1200 on 1700, the pump block top won't have contact with your processor, so be careful. Everything is written on the plastic covers, on the plastic standoffs, and you can't miss that. Placing the standoffs, you actually done most of the stuff on the motherboard. After that, you have to put two brackets on your pump block bottom, and basically this is the cool thing, because when you place the RGB cover on your pump block top, it's magnetically connected. So the magnet is so strong that it pulls the screws when you're connecting the brackets, and that gives you a bit of, I would say, ease of attaching those if you're doing it like I did, where the radiator is already pre-attached to the case. But that's my fault. Do that separately outside of the box, outside of the case, so you don't have any issues. After you place the brackets on the pump block top, you just have to place it on the plastic standoffs and then tie them up and tie the block up with the thumb screws. That's everything you need to do, because the thermal paste is already pre-applied of the bottom part of the pump block. So yeah, that's that. Now for the thermals, Intel Core i5-13600K DeepCool LT720 cools down the 13600K in AIDA 64 Extreme Edition. So CPU, FPU, cache and system memory and GPU, of course, went up to maximum peak at 77 degrees Celsius. The gaming goes up to 65 degrees Celsius, and basically in AIDA it kind of goes up and down from 70 to 77, but that's quite alright, I would say. In terms of, we have, as already stated, for some past reviews for the processors and everything else, that we have new higher temperatures and stuff like that. I checked other reviews to see the thermals and what we got and what they got, and basically this is some sort of an average. So the LT720 really does cool nicely the 13600K, especially in gaming and after all in synthetic benchmarking. But if you go and do some renders and stuff like that with 13600K, it won't be longer than 10, 15 or even 20 minutes. This was a test running for 30 minutes just in case for you guys to have some sort of insight about the thermals, what you could expect. The GPU went up to 63, but that's nothing to do with the AIO actually. So basically what we got is a cool new design on the pump block top. We got some great thermals, and I think the LT720 would be much better in cooling compared to the past model. So yeah, there's that. If I get a chance to actually use the LT720 on the processor that I use with the LS720, then I'll write it down in the comments to give you more insights, basically the comparison between those two. But all in all, it's quite cool. The only thing that shines is the block, so basically the fans are non-RGB, but still they provide good airflow, great air pressure, and definitely suited for the radiator. Guys, if you're interested in checking out the DeepCool LT720 360mm addressable RGB AIO, you can check that out in the description with the link that I provided for you guys, so you can check out also the prices as well. And that will be it for today. If you're new to the channel, guys, don't forget to subscribe, and if you really like the video, don't forget to hit the notification bell so you don't miss any future content. That's it. That's all for today. Hope you have a good one and hope I'll see you next time in a new video. Thanks for watching. Bye bye.